Hey guys, today we're going over how to find probabilities or areas under the standard normal distribution using the z-table. In my last video, I went over how to calculate normal distribution probabilities using the TI-84 calculator, so go ahead and check out that video if you're interested. Before we get into using the z-table, let's first talk about the standard normal distribution. The standard normal distribution is a normal probability distribution with mean mu equals 0 and standard deviation sigma equals 1. The density function for the standard normal distribution is given by the following equation, and the graph of this function produces a familiar bell shape you might have seen before. We denote this distribution using the following notation. Notice that the standard normal distribution is symmetric about the mean, which is located at the axis of symmetry. Another important property is that the total area under the probability density function is 1, and this is going to be useful when we calculate certain probabilities using the z-table. The values on the horizontal axis represent z-scores, which represent the number of standard deviations above or below the mean. Notice that the z-scores can be negative, positive, or 0. The standard normal distribution satisfies the empirical rule. The rule states that about 68% of all data values lie within 1 standard deviation of the mean, 95% lie within 2 standard deviations of the mean, and 99.7% lie within 3 standard deviations of the mean. Now we're going to learn how to find areas under the standard normal distribution using the z-table. Here's the table we're going to use in this video. Notice that the table has a section for negative z-scores and one for positive z-scores. Let's take a look at the standard normal distribution and focus on the positive z-score section of the table. The same idea will apply to the negative section of the table. As I mentioned earlier, the values on the horizontal axis of the standard normal distribution represent z-scores, and when we look these up on the table, we'll have to refer to the first column and the top row of the table. We'll look at an example shortly. Each value in the body of the table is the area under the standard normal curve to the left of some specific z-score, which we'll call A. The area represents the probability that z is less than or equal to A, or equivalently, the probability that z is less than A. Keep in mind that this is only true for continuous random variables, which I mentioned in my previous video. Now let's take a look at an example. Let's say we're interested in finding the probability that z is less than 1.28. We'll start by drawing the standard normal distribution, label the z-score at 1.28, draw the boundary line above it, and shade the area to the left of 1.28. Since we're working with a positive z-score, we're going to look at the positive section of the table. Now, 1.28 is the same as the sum of 1.2 and 0.08. So let's go to the first column to find the row containing the z-score to the 10th place. So we want to locate 1.2. Then we're going to go along the top row to locate the column that contains the 100th place of the z-score. So we want to find 0.08. We will find the probability that z is less than 1.28 at the intersection of the row and column, which is 0.89973. This probability represents the area under the curve. Let's do another example. Say this time we want to know the probability that z is less than negative 1.54. Let's draw the standard normal distribution, label the z-score at negative 1.54, and shade the area to the left of this value. This time we will use the negative section of the table since we're working with a negative z-score. First, let's locate the row containing the heading negative 1.5 in the first column. Then find the column with the heading 0.04 on the top row. At the intersection of the respective row and column, we get 0.06178. The probability that z is less than negative 1.54 is 0.06178, and that represents the area to the left of negative 1.54. Now we will look at the probabilities of the form where z is greater than some specific value. Let's say this time we want to find the probability that z is greater than 1.28. Again, we'll start by graphing the standard normal distribution and labeling it, but this time we'll shade the area to the right of 1.28. Recall that the table only gives us the area to the left of z-scores. We know from a previous example that the probability that z is less than 1.28 is 0.89973, and this represents the unshaded part of the graph. So how do we find the area to the right of 1.28? Well, we know that the total area under the curve is 1, so if we subtract 0.89973 from 1, we get 0.10027, and this probability represents the area that we want, so that's our final answer. Now, what we're actually using here is called the rule of complements. which says that the probability of the complement of event A is 1 minus a probability of event A. And you've probably seen this in the chapter on probability that covers the addition rule and multiplication rule. Applying this rule to the probability that z is greater than a, we get 1 minus the probability that z is less than or equal to a, or equivalently, 1 minus the probability that z is less than a. So applying this rule to the probability that z is greater than 1.28, we get 1 minus the probability that z is less than 1.28, which is equal to 1 minus 0.89973, and this equals our final answer, which is the same value we got before. Let's try another example, but this time we'll use a negative z-score. Here we want to find the probability that z is greater than negative 1.54. Let's go ahead and label everything and shade the area to the right of negative 1.54. From a previous example, we found that the probability that z is less than negative 1.54 is 0.06178. So how do we get the shaded part of the graph? All we have to do is subtract 0.06178 from 1, and we get 0.93822. We can show this work by hand using the rule of complements, as we did before. Next, we want to look at how to compute probabilities where z is between two specific values. Probabilities of this form will require looking up two z-scores on the table. Let's say we want to find the probability that z is between negative 1.54 and 1.28. Let's graph and label the standard normal distribution. Here we shade the area between negative 1.54 and 1.28. Now let's look at this carefully. We'll start by drawing two additional standard normal distribution curves. To find the area bounded by negative 1.54 and 1.28, we first look up the area to the left of 1.28, which we already know is 0.89973 from our previous example. Then we look up the area to the left of negative 1.54, which gives 0.06178. What we're doing here is taking the larger area, or the area to the left of 1.28, and subtracting the smaller area, or the area to the left of negative 1.54, and that equals the area between negative 1.54 and 1.28. In other words, subtracting 0.06178 from 0.89973, we get 0.83795. In general, to find the probability that z is between a and b, we first find the probability that z is less than b, and then subtract the probability that z is less than a. And this is a formula that we use to compute this type of probability. In the previous cases, we looked up probabilities based on given z-scores. Now we're interested in finding z-scores when given probabilities or area under the standard normal density function. Let's look at an example. Suppose that the area to the left of an unknown z-score is 0.90. Our job is to find the z-score associated with this area. How do we know whether we use the negative or positive section of the z-table? Well, if we look at the positive section of the z-table, you'll notice that the cumulative probabilities range from 0.5 to 0.99997. With that out of the way, let's locate the probability closest to 0.90. So we're going to scan the inside of the table, and we see that the probability closest to 0.90 is 0.89973, which corresponds to a z-score of 1.28. Let's try another example. This time we're given a cumulative probability of 0.10, or in other words, we're given that the area to the left of an unknown z-score is 0.10. Notice that this probability is less than 0.50, so we're going to look at the negative section of the z-score table, since the probabilities inside of the table vary from a number close to 0 up to 0.50. Again, we're going to scan for a probability close to 0.10, and we find that 0.10027 is the closest probability, which corresponds to negative 1.28. Notice that the z-score is the negative of the z-score that we found in the previous example, and that's because of the symmetry of the normal probability distribution that I mentioned earlier in the video. By the way, I just want to quickly point out that if you see a problem where you're given the area to the right of an unknown z-score, all you have to do is subtract that area from 1, and then we look up the probability on the table to find the z-score. In this case, after subtracting 0.10 from 1, we get 0.90. And we already know from our previous work that the z-score that corresponds to this probability is 1.28. Alright, that should do it for this video. In part 2, we will apply the ideas we learned in this video to a normal distribution word problem. I'll see you next time.